This is part 6 of section 2.6. We want to find all of the solutions to this polynomial. So first of all, let's use Descartes' rule of signs to figure out how many positive and negative solutions we can have. So here, let's count the number of sign changes. 1, 2, 3, 4. So I have 4 or 2 or 0. Remember, you subtract 2 until you hit either a 0 or a 1. Okay, now for negative, change the signs on your odd exponents. So negative, negative, positive, 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 positive. That's one sign change. So I definitely have at least one negative solution. Now let's get our P over Q values. Our Q value is 1, so our P values are also our P over Q values. So this comes from the 4. So my possibilities are 1, 2, and 4. Okay, so since I know I have a negative solution, I'm going to start off by testing my negatives and hopefully to get something that's a little bit easier to deal with. So I'm going to test -1 first. Okay, bring down the 1, -1, -3, +3, 2, -2, 6, -6, -16, +16, and that's 20, which is not a solution. And since I was testing a negative, I look for alternating signs and I don't have that either. Okay, so I don't have a lower bound and I don't have a solution yet. So let's check -2. Bring down the 1, -2, -4, 8, I can't multiply, that's 7, and -14, -6, +12. I'm seeing alternating signs here, which is helpful, and I also have a solution. So one of my 5 solutions is -2. Okay, I only had one negative solution. I found it, so I'm not going to test any more negative numbers. But even if I did have more, I wouldn't test -4 because this is a lower bound. It's possible that -2 would work again, and I might possibly want to test it again if I didn't know that there were only one negative. Okay, so now let's write this depressed equation and see if what we can find out now. So this will be x to the 4th minus 4x cubed plus 7x squared minus 6x plus 2 equals 0. Okay, I can reduce the number of things I have to check because now my p-value comes from a 2 instead of a 4. So that means that my new p over q values, q is still a 1 here, are ±1, ±2. And since I know negatives aren't the solutions, I just need to test 1 and 2 now. So let's test 1. No, sorry, making a mistake. I need to use these values. So 1, -4, 7, -6, and 2. Although it would technically work in your original, but you want to use your depressed equation. 1, because it's easier, because you're going to have fewer numbers to work with. And 2, because if you get an answer more than once, you're not going to find it unless you use the depressed equation. So here, bring down the 1, multiply, add, multiply, and add, and multiply, add, multiply, and I did find another solution. So one of my other solutions is a 1. So what I know now is that I have at least one more positive solution because having only one is not an option. Now I'm going to write this depressed equation and see what I have, and I may be able to simplify things even more. This will be x cubed minus 3x squared plus 4x minus 2 equals 0. Okay, I don't think this will factor by grouping. I don't see anything special. I would look at new p over q values, but this was a 2, this is still a 2, so I didn't get to improve my solutions anymore. But notice that 1 is still a possibility, even though I have already checked 1. So I'm going to test 1 again, but in the depressed equation. So that will be 1, and then I use these values here, which are the coefficients here. 1, -3, 4, and -2, and see if it's another solution. 1, 1, -2, -2, +2, +2, and a 0. Okay, so 1 has multiplicity 2. Okay, since we got it twice. So far when we're counting the number of solutions we have 3 because we count the 2 1s separately when we're making sure that we've got the 5 solutions we want. But when you're listing your solutions in a set, you do not need to list it more than once. Okay, so now I have a quadratic which we can solve using other methods. So that would be x squared minus 2x plus 2 equals 0. And this does not factor, so let's go to the quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times 1 times 2 over 2 times 1. And this gives you 2 plus or minus the square root of -4 over 2. And this is 2 plus or minus 2i over 2, and then you can factor and reduce this fraction to 1 plus or minus I. So your other two solutions that bring us up to 5 in total are 1 minus I and 1 plus I. Okay, now one more problem. We want to find an equation of a polynomial function of least degree having the given complex zeros, intercepts, and graph. Okay, now we have a lot of information on here that we can pull off. You just don't let this scare you, okay? One of the first things we want to do is to try to figure out the smallest degree. And to do that, we count the number of times our graph changes directions from positive to negative and increasing to decreasing. We call these turning points. Okay, this changes direction twice. So I have 2 turning points, and that means I need to have degree of at least 1 more. So I need degree 3. It is possible for other degrees of polynomial to have 2 turning points, but we want the smallest one. And so you always just add 1 to the number of turning points. So what I know is that I should have 3 zeros. Here I have 1 of them. What I know about complex numbers says that positive I would be the other one. And then I also have a 0 right here that's given to me, which is 3. Okay, so what I know if I use my factor theorem is the polynomial I'm using I'm going to use p of x because that's what the book uses, is some number times x minus 3 times, we need to find what happens when we multiply these 2 bits together. And in this case, our a would be 0, our b is 1. So from these two, I get x squared minus 2 times a, which is 0, okay? So that whole thing is 0. Plus a squared plus b squared, that's going to be 0 plus 1, which is 1. Okay. Now, what else I know is that if I plug in 0 for x, I get negative 3. So let's find p of 0. That gives me a times 0 minus negative 3 times 0 squared plus 1, which is 1, which is negative 3a. And I know that needs to give me negative 3 as a solution. So my a value has to be positive 1. So now I can simplify up here using what we know now. And this is x minus 3 times x squared plus 1. And they want you to multiply this one completely out. So let's distribute and get x cubed plus x minus 3x squared minus 3. And then generally they want you to write it in descending power order. So rearrange those two middle terms. And there you go.